let's go ahead and get started. I'm going to move this off to the side a little bit so I've got a little bit of room to work with. So our first equation is this one, 3x plus 5x plus the quantity x plus 9. So firstly, when we've got just plus signs and stuff, remember that the parentheses don't actually do anything, so we can just get rid of them. This is really just 3x plus 5x plus x plus 9, right? So how many x's are there total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9x plus 9 equals 180. So now all we have to do is subtract 180 minus 9 is 171, and then divide. So 171 divided by 9, well, it doesn't go into 1, it goes into 17 once, right? 1 times 9 is 9. Drop down the 1, 9 goes into 81 9 times. So in this case here, x equals 19, yeah? All right, let's do the next one. Once again, once we have our equation written out, and look at, we don't have any parentheses here, so we can just combine all our like terms. We've got a 4x, we've got an x, so in total that's 5 x's, right? 4 and 1 makes 5. And then 21, 35, and 2, 2, 5, 1, so that's 58, right? And that together makes 540. So once again, we just do the exact same thing. We're going to just subtract 58. That would be 482. Yeah. And then I'm going to divide by 5 to both sides, right? Well, let me do that out now. 5 divided into 482. 5 doesn't go into 4, but it does go into 48. 9 times. 9 times 5 is 45, right? That leaves us with 3. Drop down the 2. 5 goes into 32 6 times. 5 times 6 is 30, right? Leaving us with 2. Well, we're not done yet. We can drop down a 0. 5 goes into 20 4 times. So in this case here, we get 96.4. Now, you could also say, all right, well, 482 divided by 5, that doesn't go in at all, so we can just leave it as that fraction, 482 over 5, right? Both of these answers are fine. When you're dividing by 5, remember, you can, instead of dividing by 5, divide by 10 and times 2. Those are easier to do combined than just dividing by 5 normally. So dividing by 10, right? Dividing by 10 leaves you with 48.2, and then times 2, that's easy mental math. 4, right? So that's yet another way to do a problem like this. Let's erase, clean everything up. And then lastly, here again we have parentheses, but since it's plus signs in front of them, those parentheses are meaningless. So we can just ignore them. So we got 6x's, 4x's, and 7. So 6 and 4 is 10, plus 7 is 17. And then let's take all the numbers, 30 and 12. That's 42. Minus 2 is 40. Minus another 3 is 37. So we got plus 37 equals what? 360. So we subtract 37. You know, we can... Hey everybody, Mr. Webster from the future here, just cutting in to talk about what we did here for this first one. Normally I try to avoid making mistakes on camera when I can, but you know, we all make mistakes all the time, especially me. So when I did this in class, for some of you, not all of you, I did it right for the rest of the day, but in the beginning I didn't do this right. And we got this. This part is right, 323. And then I think I did some bad division at some point. Yeah, I've got it right here. This is the division that should have been. I think I left off the 1 here. So when you look at this, it goes in once, and then you've got 153, which is actually 17 times 9. So this goes in perfectly evenly. The answer is 19. And in fact, this did come out even, which is awesome. I totally didn't expect for any of these to come out even because I just sort of put numbers down and didn't really, you know. So, have a great day. Be well. So, what are we doing today? Today we're going to find the angle sum of a polygon. Now, by polygon, I mean any side, any number of sides. So we're not just talking about a triangle now. We're talking about any type of figure, a 4-sided figure, a 5-sided, 6-sided, 7-sided, 10-sided, 20-sided, 100-sided, 10,000-sided, however many sides. This will work regardless of how many sides that we have. And we're going to show why this works before we talk about what the actual formula for this is. So we know the angle sum of a triangle, right? 180 degrees. Anytime you've got a triangle, the 3 angles always and forever, amen, add up to 180. But when it comes to having more sides, how do we deal with that? Well, it's very, very simple. What we'll do is we will cut these figures up into triangles, and we'll do it in a way that makes it easy for us to like actually figure things out. Like instead of trying to cut it in any old place, we'll go from corner to corner. That way, all the angles of the triangle match up with the angles of the 4-sided figure. So here we've got 1 triangle, 2 triangles, so 180 and 180. So here the angle sum has to be 360. And we can do that the exact same way for any figure. Here's a 5-sided figure. Again, I only want to go along the corners so that I get all of the triangle angles matched up with all of the pentagon angles, right? So how many triangles we have here is 1, 2, 3. 3 times 540. Oh, 3 times 180. There I am spoiling. Is 540, right? And we're going to do the same thing. I'm going to continue drawing these lines from corner to corner, just on one, just so that I can break it up in a way where I get triangles here. And again, so now I've got 4 triangles times 180 had better be 720, right? So a 6-sided figure is 720. Okay, 3 times 180. This one is 4 times 180. This one is 5 times 180. All right, how did I know that? Well, look at the pattern. 3 sides, 1 times 180. 4 sides, 2. 5 sides, 3. 6 sides, 4. Now we've got 1, 2, 3, 4, 5, 6, 7, 8. Ooh, 8 sides. I skipped one, didn't I? This is actually going to be not 5 times 180, 6 times 180, right? And again, you ask yourself, well, how did he know 6 times 180? How did he figure out that was the pattern? Well, look at what's happening. Every time I count the number of triangles, it's the number of sides subtracted by 2, right? So the thing of it is, here's our formula. N, an n-gon, a polygon with n sides, so they use the term n-gon here for polygon. So an n-gon is a polygon with n number of sides. So if it was in this idea, like here's some things that we know, like a triangle. A triangle, 3-sided figure, we would refer to this as a 3-gon. I know that sounds dumb, but if we're gonna learn something new, we got to make sure that we can bring it back to the things that we already know. Yeah, a quadrilateral. Four-sided figure, right? And we know pentagon, hexagon, 5 sides, 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, 9 sides. Decagon, 10 sides. Now they're not going to use this, but like you could even go further. Unidecagon, dodecagon's one they're going to use a lot because 12-sided figures are really common. Dodecagon. That's 12 sides, so a 12-gon. And then anything that doesn't have like a really common established name will just go number gon. And that number will just tell you how many sides there are. So if you want to know what all the angles together add up to, take the number of sides, subtract by 2, and then take that new number, multiply by 180. That's all it's telling you. All right? So here we go. What is the sum of the interior angle measures of a heptagon? Well, hepta, that's a 7-gon, right? So what am I going to do? I'm going to do this. I'm going to do 7 minus 2 times 180. Well, 7 minus 2 is 5. 5 times 180 is 900. Don't overthink this. If you write this out here, This is more than enough. This is good. This is the most I'd ever have you write. So write this and be happy. Look for this keyword here, sum. Okay? And then also look for this keyword, interior. All right, give this next one a try on your own. I'm going to put 2 minutes on the clock. Actually, I'll put 3 minutes because they're asking for 2 different things here. Okay, so let's go through. This is sort of a 2-part question, and it says, first of all, what's the sum of the interior angle measures of a 17-gon? Well, n minus 2 times 180. Well, what's n here? They tell us n is 17. So all we're going to do, 17 minus 2 is 15 times 180. Well, what is that? Let's do it out. 5 times 0 is 0. 5 times 8 is 40. 5 times 1 plus 4 is 9. And then do the same thing. 0, 8, 1. So when you take all 17 angles and you add them up, you better get 2,700 degrees. Every time, no matter what. So now part 2 is, okay, so now I know that the sum is 1980. How do you find the number of sides? Well, let's do that. Now, remember, sum equals this. Well, I don't know n, I know sum, right? So let's put that in here. And then I want to find n, right? So there's a couple different ways to do this. You can either divide by 180 first, or distribute and then solve. I'm going to distribute because it doesn't matter. And I'm going to flip this around. 180n minus 2 times 180 is 360 equals 1,980. Let's add. So what do I get? I get 180n equals 8 plus 6 is 14. 12, 13, like that. And then I'm going to divide by 180. And let's figure that out. First of all, if you see a trailing 0 on top and on bottom, you can divide out that factor of 10 immediately to make your life much easier. 180 divided by 10 is 18. 1,340. Oh, 2,003. What? What did I do? Yeah, it's a 2,340. Sorry, because I forgot to carry the 1. Silly me. I'm sorry. I fixed it. 2,340 divided by 10 is 234. So let's go ahead and let's divide this out. I've made my life a little bit easier by canceling out these zeros. So 18 into 23, that can happen once. That leaves us with 5. Bring down that 4. 18 times 3 is 54, right? That comes out exact. So the answer to part B is that if the angle sum is 1,980, it better have 13 sides. And you can double check that that works by doing it back in, right? 13 minus 2, which is 11, times 180, does give you 1,980, right? So that's all we're talking about there. All right. Next, we want to sort of have a talk about some terminology, because this is going to come up over and over and over the more that we go through different shapes. When we were talking about triangles, all three of these things were the same, right? We talked about how if it's got the three sides are the same, that tells us that the three angles were the same for a triangle. And vice versa. So for triangles, this is true. That's the only shape simple enough to get this. Everything else, you could draw four-sided figures even where it has all the same sides, but not all the angles are the same, right? An equilateral four-sided figure, for example, that's not equiangular, we could talk about a rhombus, and we will. We will be talking about that next week. So if it's equilateral but not equiangular, we could be talking about like a rhombus, right? The four sides are the same, but maybe it's leaning to the side a little bit. Equiangular that's not equilateral, well, then we could be talking about a rectangle, right? A rectangle has four right angles, but not all the sides are the same. And then a regular polygon is where it has both. And that's where we're talking about a square. All right? So just be aware. Equilateral, equiangular, and regular are three different special types of figures with three different situations, unless we're talking about a triangle. For a triangle, all three of these are the same because it happens that way. But for everything else, they ain't special. They have to be split up. All right? So the reason why we want to talk about that, equilateral and equiangular, we'll get back to later. The one that we are focused on right now is regular. Right? We want everything to be the same. Because if we know that all the angles are the same, then we could figure out what one angle is. Because if we know that, like for example, every time that we have a triangle, we know that the angles add up to 180. If all three were the same, we said that for an equilateral triangle, every time the angles make 360, make 60 degrees each, right? Because we knew that they added up to 180. We could divide them by 3. 180 divided by 3 is 60 for a triangle. So, if you're ever asked to find one angle, here is what you do. Because some people get confused just looking at this. So step 1. Find the angle sum. Step 2. Divide by the number of sides. I'm taking extra special time with this because, and I'm telling you in advance that this is going to happen, and some of you are going to be sad when it happens because you weren't listening. The mistake that gets made all the time is to switch these processes for some reason. If they want to find, I'll say, find the angle sum, and then they will n minus 2 times 180, and then they'll divide by the number of sides. That's not the angle sum. That's one angle. Or I'll ask for one angle, and then they'll give me the angle sum. Don't get it twisted. Find what you're being asked to find. Think about what you're being asked to find. Pay attention to what you're being told to find. If you are trying to find one angle, first find the angle sum, then divide by the number of sides. I'm telling you this, and I say this every year, and still roughly half the people don't do it right because they give me one and when I'm asking for the other. If you are mindful, you will watch what you do, pay attention to what is being asked, and you will get the right answer. If you are not mindful, you will not. Simple as that. So again, key phrase right here. Measure of each interior angle. That means I'm finding one angle. One angle. So step one, angle sum. Nonagon. Nana means 9. So this is a 9-sided figure. I think I'm just going to do it out because I'm not trying to do this in my head here. 0 times 7 is 0. 8 times 7 is 56. 1 times 7 is 7, plus 5 is 12. 1260. Yeah, okay. So the angle sum is 1260. Am I done yet? No, because I want to find one angle. So look, how many angles are there? There's 9. What do they all add up to? 1260. So if 1260 is what 9 of them are, if I divide that by 9, I will get what one of them is. Yeah? Nine does not go into 1, but it does go into 12 once. Drop down that 6. 9 goes into 36 4 times. Drop down the 0. Goes in 0 times. Hey, and I'm done. Right? So my answer for one angle is 140 degrees. Yeah? Only one of these answers is correct, and it's not this one up here. If I'm asking you for one angle and you don't give me this, you will get no points. If I ask you for the measure of a single interior angle and you don't give me a single interior angle but instead give me the angle sum, it doesn't matter if the angle sum is correct. Without doing both of these, you get nothing. I'm telling you in advance. I will not have any pity for people who don't follow directions, especially on this one. This is so easy. You're sitting here at home with a calculator. You can just do it. Give this one a try. I want to know what the measure of each interior angle in a 2020 is. I picked 2020 because recently I've been watching some YouTube channels where they do like math Olympiad problems, like the Putnam exam and the different math Olympiads they have for each country. And pretty much every year there will be a couple problems where they'll use the year in the problem, so I wanted to do that. I know. I'm an awful person. You've got 2 minutes. Do it. Okay, let's go ahead and go over this. Once again, I'm trying to find the measure of each interior angle. So I'm going to go through and I'm going to say, all right, a 20/20 gon. Let's start with the angle sum. So we got 2018 times 180. Y'all have your calculator, so you could do this in 10 seconds, but I'm going to do it by hand. Why? Because. So start out with that 0. And we can be like 8 and 8 is 64. 8 times 1 is 8 plus 6 is 14. 8 times 0 plus 1 is 1. 8 times 2 is 16. And we got hundreds place, 8, 1, 0, 2. Add all that up, 0, 4, 12, 3, 6, 3. That is what all the angles add up to in a 2020-sided figure. So now let's find what one of them is. Because I want one angle. I want a single angle. That's what I mean by the measure of each interior angle. Every single one of these is the same. What is the measure of every single one of them on their own? Divided by 2020, right? So once again, we can make our lives simpler by dividing out the factor of 10 from both of these. We can start off making our lives that much easier by doing it that way. So let's now divide it out. All right, 202 goes into 3 0 times, 36 0 times, 363 goes in once. Drop down that 2. Now I'm going to guess that this goes in about 8 times. Oh, not quite. Because times 8 would be 16, 16. This is 16, 12. So times 7 is where we are. 14, 14. So this leaves us with carry the so 12 minus 4 is 8. This is carry this 9. 5 minus 4 is 1. 198. See how close we were to having another factor in there? So let's bring down this 4. So I'm going to say this is probably because times 10 would be 2020. That's too big. So it's probably times 9. 18, 18, right? So let's do our subtraction. 14 minus 8 is 6. 7 minus 1 is 6. 9 minus 8 is 1. And then so there is no way this is coming out even, but we have 179 and 166 over 202. Yeah? And then we could probably simplify this down 83 101sts. So this is about 179.83. About maybe 0.828 if I had to take a guess. But like we can leave it here. We can leave it here. One, they're never going to do this to you in the homework. I'm doing this to you right now because I want to stretch you a little bit. You're welcome. Okay. Let's go ahead. Let's move on. So here's the thing. occasionally we're going to have to find the measure of an angle. And I can go through and I can add all these up. 5-sided figure means that these should be adding up to 540, right? So what does this need to be to make all 5 of these add up to 540? Well, it would help if we knew what these 4 were, right? 110, 90, 120, 150, and x. Let's add all these up and we can subtract from 540, right? 200, 320, 470. Let me subtract over that 470. I think that's just 70, right? 470 plus 70 equals 540. So I know I'm good, right? Same idea, 4-sided figure this time. Watch what they add up to. All right, go ahead, give this one a try. So once again, remember, we're trying to find this missing angle. So we're going to add these up and set them equal to 360, right? 4-sided figure. N minus 2 times 180. 4 minus 2 is 2 times 180 is 360. So we got 360 equals these 4 angles added together. 53, 85, 120, and x. Let's add these up. So we got 205, 258, right? Add this, and this. Better be 258. Let me double check that. We got 8, 1, 248. Uh-oh, wait, hold on a minute. No? 5 and 8 is 13. There we go. That's why. So 138 plus 120, 258. There we go. Again, mental math sometimes is difficult. Don't do it, write it out. Five and 3 is 8. 2 and 8 is 10. Plus 5 is 15. 258. Always write it out. Mental math is difficult. Our brains are not specially wired for it. We're not supposed to do too many things at once. So right, 102, 258 plus 102 is 360. So this is the measurement of angle G. All right, our last idea here. So we talked about what all the ones on the inside add up to, but if we have our exterior angles, it doesn't matter what number we have, how many sides, how many whatever, the answer is always 360 when we add them all up. That's what this is saying. That it doesn't matter if you've got 3 angles, if you've got 50 angles, if you've got 150 angles, every time the angles add up to 360, no matter what. So therefore, one exterior angle is 360 divided by how many that there are, right? If we know that it's a 20gon, there's 20 sides, you do 360 divided by 20. Each of those angles on the outside is 18. If it's a 50-sided figure, well then it's like a little bit more than 7, right? Whatever it is, just take 360 divided by the number of sides. That'll get you one exterior angle. So I want to know what's one of these angles They're specifically like, hey, the measure of angle 1, but it doesn't matter which one it is. They're all the same. So I'm going to say, oh, octagon. This is an 8-sided figure. So I'm just going to do 360 divided by 8, right? Well, 360 divided by 8. Well, how many times does it go into 3? None. 36. 8 times 4 is 32, right? So we're left with 4 here. Drop down the 0. 8 times what is 40? So each of these angles is a 45-degree angle. Give this one a try now. I want a nonagon. Non means how many sides. Okay, so once again, I want to find the measure of an exterior angle of a regular nonagon. Remember, non means 9 sides. So let's do this. $360 divided by 9. 9 goes into 3 0 times. 36, it goes in 9 times 4 is 36, right? Drop down the 0. 9 goes in 0 times. So we've got 40 degrees for one exterior angle of a regular nonagon.